So now, earlier today, I went over this circuit really briefly. I made a short out of it, but what we have here is a light-dependent resistor. It says photoresistor up there, but the LDR means light-dependent resistor. Its resistance changes based on how much light is changing. Therefore, the amount of voltage across it will determine how much current flows. We also got a 1000 ohm resistor. That's going to factor into it as well. I used a 1000 ohm resistor so I can safely go up to 12 volts. And so I also added a 1000 ohm resistor for the photodiode. But the photodiode over there, it kind of looks like an LED. There you can see when I get it darker, the LEDs get dimmer. It used reverse bias. You put the cathode to the positive supply, anode to the negative supply. That's backwards from how you normally wire it up, but it safely passes current, and the amount of current that it will allow to flow through it is dependent on how much light is falling on it. Now, the 1000 ohm resistor there should not really affect that current unless you try to get a higher amount of current than what you can get through the 1K resistor with whatever supply voltage and diode drops or whatever you got in the circuit. So the light dependent resistor is going to set the current, but the resistor is going to set a maximum current depending on how much voltage you use. Hopefully that makes sense. So, any case, let's get the multimeter. So now, I got the multimeter, and you got to be careful measuring current, because if you have the meter set to measure current and you try to measure a voltage, you do a short circuit, you could blow a fuse in the meter. Maybe cause more damage to it, but most likely blow a fuse. And so, you want a gap in the circuit right there. So, we're going to move that. If you have a switch, you can put the switch in the off position, you know, if you got more of a permanent circuit, and then you can just touch the two ends of the switch so that current goes through the meter instead of the switch, if you're able to. But in any case, there we go. We got our gap right there. And again, we're going to measure current, so we're going to be careful. We're going to measure milliamps of current. It's actually going to be a little lower for a part of it, but milliamps will be the best setting all around for this. And if we're going to measure higher current, I'd have to move the red probe to where it says 10 amps. I think I did blow that fuse. But in any case, everything else, we got the red probe over in this spot there. And then black is COM for this one. You may have a meter where you got to move the black probe, the black wire, for one reason or another. But this one, COM is always... black probe is always at COM right there, that spot. So let's do this. I did practice measuring this, but not with the meter in the way. So there we go. So we got about half of a milliamp of current going through the LED there, where the light dependent resistor is controlling it. Of course, I can cover it and lower it as you see there. And we should have about 1 milliamp of current, a little bit less. There we go. Pretty much spot on, 1 milliamp of current. So I'll try not to move the photodiode, but of course, you get it darker. You can see how much it goes down. And blue LEDs, you still get some glow, even at very low currents. So I didn't plan on doing that demonstration, but that worked out pretty good, I think. So that was only 4 volts at the supply. So with the, remember the blue LEDs, green ones too, they drop about 3 volts. And so right now the other components of the circuits have 9 volts across them. Before, they were only working with about 1 volt. So when it comes to the resistive components over there, and then this is a semiconductor, but in any case, it should have about the same amount of current flowing through it. Let's do that one first. Now just come from the side over here. And so we can go to either one of those ground jumpers. It's the same connection. So typically I just keep it at one or the other. And so I need, just wasn't touching it. I thought it was. So there we go. It did go up about 50%, it looks like. And it went up more than it did before. But also I have a little bit more current going through before than I did before. I think it was like 0.95 when I did a test before filming it, but it was 0.99 when we were doing this. So this one went up about 50% with that extra voltage. Again, we got about 11, well no, sorry, the blue LED is dropping 3 volts. So before we had about 1 volt across these two components. Now we got about 9 volts across them. So about 9 times the voltage across them. So if we come over to the LED protected by the light dependent resistor right there. So it was I think half of a milliamp of current, and now it's like 3.5. So that'd be about 7 times the amount of current flowing through there. Again, probably got, you know, close to 9 times the amount of voltage across the two components. We could measure voltage across them as well. But in any case, let's go back to 4 volts just as a reminder of what we had before. So that was 3.5 milliamps of current, and we didn't change the light level at all. Now it's back to 0.5 as we saw before. This one got to 1.5, so it did go up, you know, but now it's back down to about 1 milliamp of current right there. So we got that. Now, like I said, we could look at the voltages. So why not? So this is part of learning electronics. Just whatever, like you hear there's voltages at this point or whatever. Actually measure those voltages if you can. Sometimes the voltages are so weak that measuring them actually throws off the voltage. Something to be aware of. But you should always do so. Get the meter off of measuring current as soon as possible. As I said before, now we're going to measure voltages, and that's how you can blow a fuse. If it's set to measure current, but you try to measure a voltage, then you get more current than you want, because the current flows freely through the meter, and you could blow a fuse. So always get it off measuring current. I should have did that before I even rewired any of this to measure voltage. But again, we're back to the 4 volts. We'll look at that. Looks like the LED is in a little bit better. So yeah, at a lower current, the blue LED is going to drop a little bit less. So when I say 3 volts, that is not a rock solid 3 volts. It depends a lot on how much current is flowing in. Remember, this is only about half of a milliamp of current flowing through there. And so now this one, again, it's being set pretty much by the LED. It'll probably be a little bit higher right there, or the photodiode, I mean, is setting the current. And so probably a little bit higher for the LED and a little bit less across these two components, because as you put more current through an LED, it builds up a little bit more of a forward voltage. But, you know, it's pretty close to 3. So that's when we had 4 volts. Let's see what that voltage was again. Right there, yeah, about 1.3 volts. It looks like pretty close for both of them. About 1.3 across the components, setting the current. Although the photodiode really sets the current. It's series resistor. That's one reason why I had that series resistor. I just went up a little bit extra in voltage. Maybe that would have been too much for the photodiode or the light dependent resistor by itself, depending on its resistance. So let's go to the LEDs. And now I think we will have really close to 3 volts. Okay, so it went up a bit, not quite 3 volts yet, right there. And same with that one, I'm surprised. But main thing was we had about 0.3 volts on both of these. I'll go to the LED, it's a little bit more solid. And there we go, about 9 volts, as I said before, once I got my math figured out. So I was kind of failing on my mental math a little bit. And so now we got the resistive components there, and so this one has more current flowing through. The blue LED probably got a little bit of more of a voltage across it right there, leading to a little bit less across these two components. But otherwise, their resistance and the voltage across them, 9 volts, is what sets the current. So as we change the voltage for the light dependent resistor, since it's resistor based, you know, same amount of light falling on it, more voltage equals more current. But the photodiode, we did see it changed a little bit, but like 50%, you know, from this reading right here. And so I don't know why exactly. When it gets a little bit warmer or whatnot, it starts conducting a little bit more. But we stayed, you know, relatively close to the same amount of current, even though we got 3 times the total supply voltage actually about almost 9 times, probably maybe 8 times as much voltage across the photodiode as and the resistor that's in series with it. So that probably helped to stabilize it a little bit right there as well. So that may be something you have to do in a circuit. Add some resistance just to stabilize, in this case, the photodiode. Who knows? So in any case, again, this is for absolute beginners. I'll try to give you my tips. I try to always have this power supply set to 5 volts and 20 milliamps of current, because these LEDs, these little indicator LEDs, no matter what the color is, usually there's a 20 milliamp maximum current that you want to put through them. Now we have 2 of them in parallel, so maybe we could, you know, go with 40 milliamps of current, although I knew this was going to be a lot less than 10 milliamps of current through either of them. So 20 milliamps of current was fine. But yeah, I'd try to set the power supply back to that, just so that's usually in my head. This is what the power supply is set to, and if I gotta change it, I just change it after that. And again, if you have a current setting, I always get it off of measuring current. Even if you have a power button where you can turn it off, set it to voltage, but here we actually have to turn it off to turn the dial to off. So we're good to go there. So in any case, long video, but I hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen, and check out links down below. They all help out a lot. I'll see you in the next video.